One cyber incident stopped a famous car maker, disrupted thousands of organisations, and produced a modelled UK impact near £1.9 billion. But the hackers are not the most important part. What brought Jaguar Land Rover's production to a halt was not just a network breach. It was the moment a global manufacturer discovered that every order, every supplier payment, every vehicle registration, and every delivery depended on a digital nervous system with no safe way to fail. That vulnerability was engineered long before any attacker arrived. In 2008, Indian industrial giant Tata Motors acquired Jaguar Land Rover, keeping the British manufacturing identity intact while backing it with global capital. A profitable recovery followed, turning JLR into a premium powerhouse. The business was built on high-margin luxury vehicles, Range Rover, Defender, Discovery, and Jaguar, where profitability depended on precise assembly and reliable delivery. The physical backbone of this operation is rooted in the United Kingdom. Solihull and Halewood run the massive assembly lines, Wolverhampton builds the engines, and Castle Bromwich stamps the metal panels. This network directly employs 30,000 people in the UK, while supporting another 100,000 jobs across the country. But a vehicle is only as complete as its missing part. JLR relies on roughly 700 primary suppliers to feed its just-in-time assembly lines. At this scale, keeping these plants running requires a massive, constant flow of components. There is no warehouse of spare parts waiting to be used. The factory floor depends entirely on a continuous sequence of arrivals, making coordination the lifeblood of the entire business. To survive in a fiercely competitive global market, Jaguar Land Rover had to modernize. The company poured billions into flexible manufacturing and electrification, redesigning factories to build different models on the same assembly line. Capital could not sit idle, tied up in massive warehouses of unused parts. Instead, the company adopted a highly optimized just-in-time production model. Every component, from an engine block to a dashboard clip, arrived at the factory gates exactly when it was scheduled to be installed. This approach unlocked immense profitability by eliminating storage costs and streamlining the entire assembly network. But this relentless drive for efficiency came with a hidden trade-off. By replacing physical stockpiles of parts with precise digital scheduling, the company traded tangible safety margins for digital coordination. There was no longer any spare capacity or inventory buffer to absorb a sudden shock. In this ultra-lean industrial ecosystem, even a brief delay in parts delivery would instantly stall a multi-million-pound assembly line. The tolerance for disruption had fallen to zero, leaving the physical factories entirely dependent on an invisible, highly centralized digital nervous system to keep the cars moving. At the heart of this digital spine is the Enterprise Resource Planning Platform, or ERP. This database serves as the shared record linking customer orders, parts inventory, assembly schedules, and money. Before a single sheet of steel is stamped or a chassis is welded, a vehicle exists entirely as a digital record. This file dictates every detail of the car's future physical construction, from the engine type to the color of the seat stitching. Production scheduling software uses this data to decide the precise sequence in which vehicles move down the line. It ensures that the exact parts needed for a specific car arrive at the correct workstation at the exact minute they are required. Logistics systems track and coordinate thousands of components from hundreds of suppliers, managing a tightly timed flow of parts. When this digital system is taken offline, the physical assembly line machinery and manufacturing robots remain completely functional, untouched by the intrusion. However, the factory floor loses its map. Without the central digital record, scheduling ceases. Workers cannot know which car to build next, what components to install, or when to move parts from the loading docks to the line. Physical assembly cannot proceed without its digital blueprint. Once a car is physically assembled, its journey is only half over. It cannot leave the factory gate without its digital birth certificate. Every vehicle requires a unique birth record containing quality control logs, component serial numbers, and safety certifications. Without these verified digital files, a completed vehicle is legally incomplete, unable to be registered or sold. The digital trail extends directly to dealerships. Sales, wholesale, and retail systems must link the physical vehicle to a buyer. This connection relies on automated registration databases to assign license plates and process road tax records. Simultaneously, the financial machinery operates on the same digital network. Automated invoicing platforms process deliveries to trigger payments. When a vehicle is wholesaled to a dealership, the system clears the invoice, unlocking cash flow and initiating payments back to the hundreds of suppliers who provided the raw materials. This dependency continues long after the sale. After-sales operations, including spare parts tracking, warranty claims, and routine service scheduling, rely on the exact same central database. Software does not turn the wrenches or run the stamping presses. Instead, it acts as an invisible coordinating layer, authorizing and validating the physical handoffs that transform raw steel into a legally saleable, financially settled asset. In late August 2025, security teams at Jaguar Land Rover detected anomalous activity inside the corporate network. To stop any lateral movement, the company initiated emergency containment protocols. By September 1st, reports emerged of a sudden, global halt in vehicle production. On September 2nd, JLR publicly confirmed a cyber incident, announcing that internal systems had been taken offline. The company framed this drastic step as a defensive measure to protect data, safety, and business operations while forensic investigations began. Although JLR stated that some data had been affected, the actual scale and nature of any data theft remain unverified. While the National Cybersecurity Center and law enforcement agencies were called in to support the response, their investigations remain distinct from the company's internal operational updates. Industry analysts and media reports soon linked the disruption to specific cybercrime groups, but these attributions, alongside entry methods and ransom details, remain unconfirmed. Importantly, there is no evidence of direct compromise to operational technology, such as robots or factory floor controllers. In a highly integrated environment, corporate IT and operational networks are heavily linked. Isolating the entire IT network is a standard containment practice to protect physical operations, meaning a complete production freeze can occur as a deliberate security choice rather than a direct hack of the assembly line itself. The initial pause did not last. On September 9th, Jaguar Land Rover announced the first extension of the manufacturing freeze. A second extension followed on September 16th and a third on September 23rd, pushing the anticipated restart date to at least October 1st. Inside the massive assembly plants at Solihull, Halewood, and Wolverhampton, the physical machinery stood ready. Stamping presses, robotic arms, and welding bays were completely operational, but they remain motionless. Thousands of workers still reported to their shifts on the factory floors, surrounded by silent equipment and stacks of unused parts, unable to build a single vehicle because there was no safe, digitally traceable sequence to guide them. On September 25th, the company managed to restart a limited number of core computer systems. While this allowed JLR to clear some supplier payment backlogs and resume limited parts shipments, severe production constraints remained. The disruption was no longer an isolated IT problem. It had transformed into a systemic industrial paralysis. This paralysis hit the supplier network hardest. JLR's just-in-time model requires constant coordination with roughly 700 primary suppliers. When the central ordering database went dark, these suppliers lost all visibility of incoming orders and invoice processing. Small and medium-sized parts factories across the West Midlands and Merseyside saw their order books instantly vanish. Although their own computer systems were secure and untouched by the incident, These uncompromised firms faced immediate cash flow pressure as unpaid invoices piled up. To survive, some Tier 1 and Tier 2 suppliers began cutting shifts, reducing working hours, and laying off staff, sending economic shockwaves through West Midlands and Merseyside communities. Downstream, the impact reached the retail network. Dealerships lost access to the wholesale delivery and registration portals. This blackout coincided with the UK's highly anticipated September New Plate Day, one of the busiest sales windows of the year. Unable to register vehicles, arrange customer financing, or process delivery paperwork, dealerships watched completed cars sit orphaned in factory storage yards. For customers, the outage meant indefinite wait times. Vehicle deliveries were postponed, and service centres struggled to obtain replacement parts for routine maintenance and warranty repairs. Online automotive communities and cybersecurity forums quickly filled with a mixture of disbelief and frustration. The event demonstrated that a modern premium car maker operates as a software platform, meaning a digital disruption can cripple hundreds of companies that were never actually hacked. The disruption had changed from an unavailable corporate database into a weakening industrial network. In November 2025, Jaguar Land Rover's official financial disclosures laid bare the balance sheet damage of the autumn disruption. The company reported an exceptional cyber-related cost of approximately £196 million, representing the direct bill for cybersecurity consultants, forensic investigators, and system restoration work. This specific accounting charge pushed the manufacturer into a broader £485 million pre-tax loss for the 3 months ending September 2025. This overall quarterly loss occurred alongside other heavy operational pressures, including the planned wind-down of older Jaguar models, global market weakness, and mounting tariff uncertainties. Keeping these macro factors separate from cyber-specific losses is essential to understanding the true state of the business, as distinct from independent external estimates. These official disclosures paint a clear picture of a manufacturer caught between internal digital isolation and external economic headwinds. Nevertheless, the forced shutdown left a deep mark on British industrial output. BBC reporting showed that overall UK car production plummeted 27% in September, marking the lowest September output since 1952. While that figure represents the entire British automotive sector, the idle assembly lines at Solihull, Halewood and Wolverhampton were the primary driver of the collapse. For JLR and its parent company, Tata Motors, the quarter ended with weakened revenues, lower wholesale volumes, and strained corporate liquidity, showing how closely physical assembly and digital networks are bound. To capture the full scale of the disruption, the Independent Cyber Monitoring Centre analysed the event using a broader lens. They classified the incident as a Category 3 systemic event, a designation reserved for severe external cyber threats that generate substantial economic consequences. Rather than looking only at Jaguar Land Rover's internal corporate balance sheet, the centre modelled the financial shockwaves moving outward across the entire UK industrial ecosystem. Their model estimated a total UK economic impact of between £1.6 and £2.1 billion, with a midpoint of roughly £1.9 billion. This estimate represents a modelled projection of the wider economic damage, not a confirmed direct loss on JLR's financial statements. To reach this figure, the methodology calculated the cascading losses suffered by roughly 5,000 connected UK organisations. It incorporates lost output from suppliers who had to halt their own production lines, downstream dealerships unable to deliver finished vehicles, independent service centres starved of spare parts, and the resulting slowdown in ancillary logistics and economic activity. The significance of this nearly £2 billion estimate is not that JLR paid this bill, but that it demonstrates how a single digital vulnerability in one firm can quickly translate into a macroeconomic shock across an entire nation. Restoring the physical assembly lines required fixing the broken financial pipeline first. To relieve the immediate cash crunch, Jaguar Land Rover established a £500 million accelerated payment arrangement, giving qualifying suppliers early access to vital capital. To secure broader stability, the UK government stepped in with a £1.5 billion loan guarantee under its Export Development Guarantee structure. This was not a taxpayer bailout, direct grant, or public payout. Instead, the state guaranteed commercial borrowing to protect supply chain liquidity and safeguard thousands of manufacturing jobs, leaving JLR fully responsible for repaying the lenders. With the financial foundations stabilized, the physical recovery followed a strict sequence. JLR announced a phased restart on September 30th. On October 7th, workers returned to selected operations, beginning with the Electric Propulsion Manufacturing Centre and the Battery Assembly Centre in the West Midlands. Alongside stamping lines at Castle Bromwich, Halewood and Solihull, vehicle assembly moved toward normal levels later in October. This carefully managed sequence demonstrated that a modern manufacturer cannot simply flip a switch to resume production. It requires finance, logistics, verified digital records, and physical components to be brought back online in perfect harmony. Ultimately, the crisis revealed that cyber resilience and recovery capacity are no longer just IT concerns, they are core manufacturing capabilities. Isolating the network was the correct containment choice, but it exposed how little safe continuity remained without centralized digital systems. The pursuit of efficiency had systematically removed the spare capacity and physical buffers that once absorbed unexpected shocks. This extreme centralization turned a local IT breach into a contagious network-wide shutdown. Modernization itself was not the error. Rather, the vulnerability lay in constructing a physical industrial empire around a single digital thread without designing alternative ways to operate. Future manufacturing strength depends on building network segmentation to restrict a breach, creating manual protocols to maintain basic assembly, and establishing supplier continuity plans to protect the cash flow of independent partners. This prevents a localized IT failure from turning into a partner's financial crisis. Ultimately, this crisis proved that digital resilience is no longer an IT policy. It is a core industrial capability, as essential to physical production as steel, machinery, and the assembly line itself. Today, the true measure of industrial strength is no longer horsepower, but digital self-defense. As supply chains grow more interconnected, a manufacturer's greatest vulnerability is no longer the factory floor, but the code that binds it. Cyber resilience is now inseparable from the ability to build cars. What do you think this means for the future of heavy industry? Let us know in the comments.